Hello, welcome to physics. I am teacher Phoebe, and today we'll talk about electrostatics. Electrostatics is the study of stationary charges. This is important in studying electricity and magnetism. For us to understand electrostatics, it is important to study first electric charge. Electric charge is a fundamental property of matter that's carried by elementary particles. When we say elementary particles, that refers to the subatomic particles of an atom, the neutron, electron, and protons. The electric charge of an object is related to the net charge of an object. Take note that an object can have many atoms inside it. Therefore, it has many electrons and protons inside it. Now, the net charge of an object is the total number of electrons and protons inside the object. So, we can say that the object can have electric charge, or the object can be electrically charged when the object is negatively charged or when the object is positively charged. When the object is neutral, we say that the object does not have a charge. So, when does the object becomes neutral? It is when the object does not interact with another object. That means that the number of electrons and protons inside the object are of equal number. Now, when the object is negatively charged, that means that it has more electrons compared to protons. As we see in the illustration, we have here 6 electrons and we have 4 protons. Now, for a positively charged object, we have more number of protons than the electrons. As we see here, there are 6 protons and we have 3 electrons. So when the net charge of the object is negative, that means that the electric charge of the object is negative. When the net charge of the object is positive, that means that the electric charge of the object is positive. Okay, so again, when we say negatively charged, that means that the object has more electrons, therefore, it gains electrons. Okay? That means that it gains electrons when we interact them with another object. Now, if the object is positively charged, that means it loses electrons, thereby having more number of protons than electrons. Okay, so it is the electron that is being transferred from one material to another. Okay, so because as we know in an atom, in the structure of an atom, the electrons reside to the outer orbitals of an atom. Therefore, it is the electron that can be easily transferred, or we need lesser energy for electrons to be transferred from one atom, from one object to another. So they are the ones that mostly interact with another atoms. Now, experiments show that whenever we will place electrically charged object near an electrically charged object, they will interact and it will show us either repulsion or attraction. So when two objects are of the same charge, as we see in the first illustration, we have two objects that are of positively charged and we place them near each other, they will repel. And in the second illustration, if the two objects that are electrically charged and they have opposite charge, one is positive, the other is negative, they will attract. Okay, now, again, when we talk about making objects electrically charged, we have to let them interact with each other. So we call that one methods of charging, and there are 3 methods. So first one is charging by friction. So that's what I mentioned a while ago. Charging by rubbing. So electron is transferred from one object to another. In the illustration here, we have 3 scenarios. First is that 2 plastic rods are wrapped with fur. And after rubbing them with fur, the 2 plastic rods become negatively charged and the fur becomes positively charged. In the second scenario, we have here two glass rods rubbed with silk. So after rubbing the two glass rods with silk, the two glass rods become positively charged and the silk becomes negatively charged. And when we place the two rods, one is the plastic rod and the other is the glass rods near each other, they will attract because they are of opposite charge. Same with the glass rods and the silk when placed near each other, and the plastic rods and the fur when placed near each other, they attract. Okay, so this will really tell us that um, two opposite charges placed near each other will attract. Okay? So between two objects that are being rubbed, how can we determine which will become positively charged or negatively charged? So, like the plastic rods and the fur. How do we know that it will be the plastic rod that will be negatively charged and the fur will become positively charged? How do we know or how can we determine that the glass rods will become positively charged and the steel will become negatively charged? So we can do that by following the triboelectric series. So triboelectric series, we can also call this one the electronegativity series. So it's related to the electronegativity of an atom, wherein it shows us here the rank of sample materials based on their electron affinity. So when we see electron affinity, that is the tendency of an atom to gain or to lose electrons. So after interacting two or more objects, um, the electron affinity will tell us which one will more likely become positively charged and which one will more likely become negatively charged. So the greater the electron affinity of the material, the greater its tendency to become negative. Why? Because the greater its tendency to attract electron. So as we see here, as we go downward, it will give us a trend of increasing electron affinity as we go downward. As we go upward, that's decreasing electron affinity. So glass here shows that uh, it has more tendency to become positively charged than negatively charged. Cotton here has more tendency to become positively charged than negatively charged. How about the rubber, the plastic rod or the rubber rod? It has more tendency to become negatively charged than positively charged. Okay, so definitely we can use this um, series for us to somehow determine or predict which one will more likely become positive or negative after the interaction. Okay. So second method of charging is charging by conduction. So this is also called charging by quantum. So electron is transferred from one object to another, creating um, an electrically charged material by placing a charge or by placing the electrically charged material in contact with a neutrally charged material. So the first object is electrically charged already, that's a negatively charged, and the second material is neutrally charged material. This one here in color orange. Now, when we place this electrically charged material near the neutral charged material, there is what we call it separation of charge. Okay, separation of charges. So since the other one is electrically charged and it's negatively charged, the neutral material will have separation of charges. So the positive charges here or the protons here will move towards that side near the side of the one that's um, near to the negatively charged particle. While as you see, the negative sign here moves to the other side. So there's separation of charges. Now, when we let them in contact with each other, some of the negative, some of the electrons here from the already electrically charged will transfer to the neutral charge material, making the other material as a negatively charged material. So the neutrally charged object here becomes negatively charged. And the last diagram here shows that even if we already separate the two objects, we did not contact them anymore here, still these two objects are already electrically charged, and both of them are negatively charged. So what will happen when we place a positively charged object here, not negatively charged, to the neutral object? So what will happen at the end of uh, the completion of charging by conduction, both will become positively charged. Okay, so if because if it's positively charged, then in charge separation, it will be the electrons that will move to this side, then the protons, and then the electrons, when we let them contact with each other, the electrons will be transferred from the neutral object to the positively charged. So although electrons are transferred, but still the positively charged material um, will not be overcome with the electrons transferred. So still it will remain positively charged. However, the neutrally charged material becomes positively charged as well after transferring some of the electrons to the other material. So both will become positively charged if it's the other way around, if it's the positively charged material that's placed near a neutral object. Okay, so the difference is that one is electrically charged and the other is um, neutral, while in charging by friction, it can be that both are neutral. The two objects that are interacting with each other are both neutral initially. Right. Now let's go to charging by induction. So charging by induction does not need contact with the other material. So objects do not need to have contact with each other. It can already induce um, the other material to be electrically charged. So situation here shows us that initially this metal ball is uncharged, meaning it's neutral. Now, when we place a negatively charged particle or object near the metal ball, which is neutral, there is charge separation. So even if there is like a gap of space in between, but still the negatively charged rod here affected the orientation of the protons and electrons inside the metal ball. So some of the protons will move to this side, and some of the electrons will move to the other side. Now, when we put a wire, or when we connect a wire to the metal ball, the electrons here will go downward. So it will flow to the ground. So leaving the metal ball more positively charged than negatively charged. So now we induce a charge to the ground, we also induce a charge to the metal ball. The metal ball becomes positively charged and the ground also becomes negatively charged. So even if we put this away from the metal ball, the negatively charged rod, still the metal ball is now electrically charged, and that's positively charged, and also the ground. Okay, so it's actually similar to the concept of the idea that's being used by this one, three-pronged plug. So um, there are actually three wires inside. One is a hot wire, the other one is a neutral wire. So these two are essential wires, but this round round metal here. This one is for the ground. Okay, and we usually have this kind of plug in our appliances. That one is for the ground. Sometimes we cut this one, but actually that has also served its purpose at times when we have this kind of plug. Okay. Now, methods of charging follows the law of conservation of charge. When we say conservation of charge, that means that the algebraic sum of all electric charges in any closed system is constant. So no charge is created nor destroyed, meaning when we interact two or more objects with each other, no charge is created. That means that it's just simply being transferred from one body to another body, from one object to another object. And again, it is the electron that is being transferred, not the proton. Okay, so I hope that you learned something for today. Thank you for watching, and let's see each other again for the next lesson. Bye!